This is Neil Schneider for MTBS-TV at CES 2013. I'm at the Omek suite. Joining me is Janine Kutliroff, and she's here to talk about their latest gesture technologies. Welcome to the program, Janine.
Thank you so much, Neil.
Now, let's talk about Omek. You have actually a tenured history. Maybe you could fill us in a little bit about the company.
Sure. We started the company 6 years ago, myself and the CTO. Our vision when we started the company was, it's a little catchy, but control everything without touching anything. The idea was really to redefine, to change the way that we interact with our devices, to change the terms, to make devices understand people instead of us being confined by the boundaries of machine language, you know, the limitations that are placed on us today, like typing on a keyboard or even swiping of a screen, to take away those boundaries and to let the machines understand us the way people understand us. And that's really what we're aiming for at Omek.
Now, you have, I understand, two product groups. You have kind of like a business group, and then you got a consumer group. Can you talk about the business side?
You mean we have two products in the market?
Yes, that's what I meant.
Okay, so we have a product that we put in the market a few years ago. It's a long-range, full-body skeleton tracking product. It's aimed at use cases like the living room, you know, TVs and set-top boxes and game consoles, really around the gaming experience in the living room, similar to what Microsoft did with their Kinect. We've enabled a game console in China with that technology. The most widespread use of our technology to date has been in digital signage applications, so large interactive advertising screens where the idea is to capture a user's attention by getting them to notice the screen and then advertising directly to them, and all sorts of fun use cases. So that product is live and has been in the market. It's downloadable from our website today. It's called Beckon. But our most recent focus in the company has been around more of a close-range interaction, an experience where we utilize the space between our PC and ourselves, or our all-in-one and ourselves, and we really change the paradigm of close-range interaction so that we can expand the experiences that we can have with our close-range devices. So it's a product called Grasp. The technology behind it is a very sophisticated algorithmic approach to understanding the movements of the hands, like 22 joints in each hand, and how they move in every configuration. So if you can imagine, the camera can't even see the hand when it's turning away. We still have to understand what that hand's doing and give that ability to an application developer to be able to build experiences.
Your colleague's actually going to give us a full demo very shortly. Let's talk a little bit about Windows 8. I mean, this is, of course, Microsoft's latest innovation for the desktop and notebook PCs, and of course they have a mobile platform as well. Can you elaborate some of the challenges that have been faced with the latest operating system and how your product fits in? Yeah,
well, that's a great sort of entree point, because Windows 8 was really built as a touch interface, and when you don't use it as touch, it's not really an intuitive type of control. You have to use the mouse and the keyboard, and it's not natural, which is really moving away from the experiences that everyone's trying to move towards. And of course, touch is certainly not in most of the larger screen devices, certainly not in all-in-ones, and even most of the PCs don't have this touch interface. Yet there's a large pressure for the world to move towards Windows 8. So what we'll show you in a few minutes is one of the most basic use cases, which is just overriding all those touch commands of Windows 8 and allowing somebody to interact with Windows 8 utilizing gesture commands, which actually makes it more natural than touch. And then we like to even think about going beyond Windows 8 and saying, okay, well, Windows 8 is still a sort of a grid framework, but what happens when you expand beyond what's meant to be a 2D interface and allow for sort of an X experience, a 3D type of experience, and how can we move that user interaction closer to how a person naturally uses? So we're going to show you Windows 8 interface with gesture, and then of course beyond.
And now we were talking about the desktop platform, or possibly the notebook platform as well. What about mobile? I mean, mobile seems extremely natural to use touch as an interface. Is there any potential in the mobile field as well?
Yeah, so mobile is a really interesting use case, in my opinion. I think that when you're holding a cell phone or a tablet or any type of mobile device, it is very natural to use touch. It's very comfortable, and it makes a lot of sense for the application. So how does this technology expand into that world, which I think it does very nicely? our devices are only getting smarter. Processing power is getting cheaper, and it's expanding in its capabilities, and more information is being stored on our mobile devices. And I think that in the near future, we're not going to be carrying around our laptops and our heavy devices. All of our information is going to be stored on our tablet, on our mobile phone, maybe even on our watch, but on the smallest devices that we certainly have on our body. And now projectors are becoming more and more common into these devices. So now I'm walking through the halls of a hospital and I'm a doctor, or we're sitting together in a meeting and I'd like to share with you my presentation material. All of a sudden, I utilize my mobile device, I project that onto my table, and my table becomes a touch surface utilizing this type of interaction. Or I project an image onto a wall, and we can share and look on a large screen, and I can manipulate that data with my hands. So I don't think it's necessarily the use case to say, hey, let's replace the touchscreen. The touchscreens are very effective. It's how do I now take this device and create an entire a new interaction with my data utilizing this device.
Now, as a company, I mean, we're talking about, Windows 8, mobile devices. Are we talking about hardware, or are we talking about software? What is it that Omek is bringing to the market?
Yeah, so we're software only. We've been very disciplined about watching the market and trying to interact with any device that really gives us a good enough depth map to take information and then to translate that information into meaningful data. So we are the software group that basically creates intelligence from the depth data that comes out of a 3D sensor. And we will work off of any 3D sensor. We'll work off of really any sensor that gives us an accurate depth map. And that market is something that more and more companies are entering into and will commoditize. And I think that being disciplined to be software only really gives our customers maximum flexibility.
Can you elaborate a little bit more as to what would be an applicable depth sensor? Like, do you have certain criteria that need to be met to be, compatible with your software?
Yeah. So we've got minimum criteria standards which nobody ever meets. So we are always work sort of below that minimum. What we need is a depth map, and a depth map means that the data, the input coming from the sensor is basically giving us a point for every pixel in the field of view. And we get that from time of flight sensors, which are single sensors which are emitting light and receiving it back from a sensor. We get it from structured light type of sensors, which are like what you've seen in the Kinect, where there's an emitter and a receiver. We've seen it from active stereo type of sensors, where we've seen the data accurate. Where we have seen reliable depth data, it's come from devices that have their own active light sources. So we haven't actually seen it yet from anything without an active light source, but the cheaper the device gets that delivers us a robust depth map, the happier we are.
Are stereo 3D cameras an applicable source of this information?
So in theory, yes. There's two categories. There's passive and there's active. So if the typical stereo cameras that most people work with, we haven't yet seen sometimes the data is good enough, but it's not consistently reliable yet to fit our minimum standards. But when we've seen those same stereoscopic cameras with their own active light sources, so we do believe based on what we've seen that they'll deliver good enough quality for us.
Okay, excellent. Now we're going to see a demo very, very shortly. Just one more question for you is, when we're talking about the software, is it being sent to the manufacturers? Is it something consumers buy separately? How do you envision this being packaged?
So we are integrating it into devices. So we're working with device manufacturers, so the DMs as well as the OEMs, the brand manufacturers, to integrate it into devices. So consumers will get it by buying the next generation all-in-one or PC. It will be inside of that PC. It will be driving that new experience where they'll be able to use a combination of their keyboard and now an entire gesture-enabled world. But it will come through, our relationships are with those who are making the devices themselves.
Do you foresee a future where there might be an option that, let's say, people buy a computer or desktop, it's got the operating system, maybe they've got a 3D webcam, or they buy a Kinect on their own. Do you foresee an option that maybe they just buy the software, license the software out separately from the manufacturer?
Absolutely. As a matter of fact, I'll take it a little further. One of the tools that we offer to developers is the ability to create their own gestures without any need to code. So if I want to say, hey, let's take that to the consumer level. If I'm a consumer and I want to say, well, hey, I have an idea. I want every time I make a certain movement, I want my device to pause. And I want to define what all those different movements are. I'm going to record a sequence of myself doing those movements and say, there's my movement. And our tools are sort of our learning tools. And they will allow the software to learn those movements, and people can start to customize their own movements. So I see a lot of ability for developers directly and consumers directly to come and to take the software and to build their own unique customized experiences with it.
Okay. Well, I just think, because we're going to see the demo in just a few seconds, but I think it's really exciting stuff. And if there's a way for consumers to just buy it on their own, despite the relationship with the manufacturer, I think it could go a long way. So thank you for joining us, Janine. Let's, enough talk. Let's see it. Okay.
Great. Thanks so much, Neil.
Okay, no problem.
So we're going to show you a demonstration today of experiences that we created in-house by our user experience studio. We are leveraging 3D depth camera. We built this demo station, creating, including inside of it a depth camera that's located here at the bottom. And what we're going to show is some experiences that we are leveraging our software product called Grasp in order to show how you can interact with these type of interfaces, 3D depth interfaces. So it's the first one I'm going to show. It's called Augmented Shaper. It is an augmented reality where we are tracking 3 points of the hand, and we're kind of pulling this rubber band around, and we can move around very quickly, can interact with multiple hands, grab points, and I mean, pulling around, interacting with the movements of the with the music, hand movements in, out, and around, and just for fun, kind of engaging experience. I'll move on and I'll say that one of the things that we have identified was Windows 8 interfaces was very geared towards touch. And when you're working with such a large all-in-one, which also has sometimes touch, it's hard to send out your hand and reach and touch each one of the tiles. So we added a very intuitive gesture-based interface to Windows 8. So you basically swipe your hand, you can virtually touch the screen and move around. I can open an application, again, navigate around, select a view. This is a 3D panoramic view of the Windows Travel application. I can walk around, navigate, can move in, zoom out type of experience. It's, again, easy, intuitive, and fast. Another example of leveraging gesture is basically interacting. Everybody knows Fruit Ninja. So I can start a new game, and what I want to show is that it's very quick, intuitive, and I'm leveraging just small movements of my finger. I don't need to move my hand all around the screen. I can just move my finger, very responsive, look around, and interact. I can also interact with multiple fingers. And then have an interface. Again, I can do a quick gesture. I'm back into the regular Windows 8 experience. I can start drawing and show you an interface where you can't leverage with a regular mouse. I can touch and draw, but the thickness of the line is really dependent on the distance. So I can make thin lines or thick lines, can write my name, and so on. This is Windows 8, but I would like to show some of the thoughts that we have invested into building the next generation of user interfaces. So this interface is called Practical UI. We have put a lot of investment in what would be the right gestures, control to interact with future interfaces. And in this example, I pick up my hand, and we have a rotating menu. Why? Because hands usually don't move in straight lines. It's easier just to rotate the hand, select a menu item. This is a demonstration only of how you can navigate your book library. And I can move in closer, I can step out, I can basically grab a book, rotate it as I would do naturally, read the back, rotate it back, can pick up a hand, grab it, open it, and it doesn't require training because it's basically the same way you would interact with the real world. So we're trying to generate very natural and intuitive ways of interacting with your devices. So I can basically grab, close it, can go to the main menu, I can go to the music again, I can browse my library by zooming in, zooming out, can grab the record, you would rotate it to the other side to see what's written on it. Again, I can also grab more than one record and compare them, open the music and interact with it. So pull it, select music, and so on. Moving on, we want to show another type of interaction in the true 3D space. So this is what we call our clay application, where we can model a clay block just with your virtual hand. I'll take a base model. And here I can start by, it's right now in a mirror mode, so I can do interactions. I can go and pinch, interact. Let me try and pull a nose here. Let's try and add a few ears. Change the brush size. Can rotate it around and look at the creation. And then when you're done, you can save the picture or send it to a 3D printer as an example. And then move on. That's just few of the experiences that we have created to show how you can leverage the depth sensor inside of the. Sure. Here is an example of an application. We are focused on making sure that the tools that we create are very easy to use and quick for time to market. So this application was created actually within 3 days, because we have plugins into Unity, frameworks to interact, and so on. So created basically a marionette where each finger controls a limb. Just as a fun experience to show how quickly it was and easy to create such an application.